I'm here with Martin. We're doing Module 10. This is On Your Own 10.7. These 7A, B, and C are talking about this term called molarity. What is molarity, Martin?
It refers to how many moles you have in a liter.
Yeah, it's what we call a concentration unit. Right? How many moles per liter?
Yeah.
Okay. So molarity is the number of moles divided by the number of liters, right?
Yeah.
So what is letter A?
2.1. Determine the concentration of acid or base for each of the following solutions. 2.1 moles of HCl in 346 milliliters of solution.
Okay, this is in the wrong units, right? Our molarity is going to be in moles per liters. So we're going to convert this to liters. We're going to keep the top as moles. And we're going to quickly convert this to 0.346 liters. Now we can do a division. This is a very easy division to do by your brain with a pencil and paper, or you can do it with a calculator. Okay, I get a number like this. How should I deal with this, Martin?
Round it.
I should not round it. Round is the wrong term because we're using science.
About. Say that it's about.
Okay, so now what we're talking about is come on.
Significant. You need two significant figures.
Yeah, so, either significant digits or significant figures, whatever you want to call it. I don't care. So how many do we have? We have 2. We have 3. You have to use your rounding skills, but how do you determine to what degree you're going to round it? Then you have to use your significant figures. So how many significant digits are we limited to? 2, because we have 3 here and 2 here. We always go with the fewest number. So we're going to round this 0 tenths to a 1/10. So 6.1 molarity is the answer for letter A. Okay. Ready for letter B?
Yeah.
Let me erase. Okay.
6.78 grams of KOH are dissolved in enough water to make 150.0 milliliters of solution. I gotta ask, is the chemical formula of the stuff important? Do we need to know?
Currently, no, but okay. You will, because you'll have to figure out the molarity soon. You'll have to figure out how many moles this means. Oh. How do we know how many moles we have?
The formula is up here.
No, the molarity. Okay, so to find the molarity, you take the number.
To get to molarity, we need moles of acid and liters of solution. So I need to convert grams to moles and ml to liters.
Okay, so how do we find out how many moles of potassium hydroxide we have?
It's grams to moles. I don't know, but it's right here. So
excuse me. You did it in a number of previous modules. Okay. So first we have to figure out the molecular mass of KOH. Use the periodic table to tell me, hold on a moment. Thank you. To tell me the AMU, atomic mass units, weight of potassium.
Okay, that's 39.1.
Okay, so the 39.1 AMU. How about oxygen?
Oxygen is 16.0.
We only have one of all these molecules. And hydrogen?
H is 1.01.
So we end up with, write all this down, baby.
Oh yeah, we just add that together.
Right. So this is, and we're going to be limited in our addition. In addition, we're limited to precision. We can only be precise to the 10th place. So 56.1. Right?
Uh-huh.
So that's how many grams is 1 mole, right?
Right.
So remember our thing. So we'd say 1 mole is the same as 56.1 grams. Okay? So we want to find out how many moles is this. So we're going to use this conversion. The other conversion unit we would use is 56.1 grams per 1 mole. Right? We did all this in the first couple of modules, all these conversions. So if you don't remember them, go back to those earlier modules, review what you did. You're going to keep needing to use it forever and ever, the rest of the year. Keep your skills fresh. So which one are we going to use of these 2 conversion units to get the number of moles of grams is? Yeah. So I'm going to erase that for my ease. Martin, make sure you write all this down. Multiply by 6.78 grams. Grams cancel. We'll find out how many moles we have by dividing 6.78 divided by 6.78 divided by
56.1.
6.1. So that gives us 0.1208556. Okay, so that's obviously too much. We have 3 here. We have 3 here. We can have 3 figures. So we're going to say 0.121 moles. Okay. So now we know how many moles. Sorry, I'm writing a big M like it's molarity. It's not. Excuse me. This is moles. So now we have 0.121 moles, and we know how much volume we have, how many liters. No, we don't. We have it in milliliters again. So let's convert that. That's going to be, so we're going to multiply that by 1 liter per 1,000 milliliters. Milliliters cancel. 1, 2, 3. 0.150 liters. So if I want to show all my significant digits, I should continue to show. This has 4. So this one wants to have 4 as well. Okay, so I still have 4.
Just divide 0.
So now we go back to our formula. So molarity is going to equal 0.121 moles divided by 0.1500 liters. Okay, this is, and the units will be molarity. That's what we just call it. So let me do that math here on my handy dandy calculator. 0.121 divided by 0.15. Okay, so that gives me 0.806666. Repeating. So I have 4 significant digits here. I have 3 here. I want to have 3, so I'm going to call it 0.807 molarity. And that is my answer for letter B.
Am I an Indian yet?
Am
I an Indian yet?
Are you an Indian yet? I don't understand.
And I thought you were a cultured woman. I don't understand my references.
Are you talking about Mowgli?
What?
I don't know.
Mao. He was raised as a wolf.
Yeah, but
he wasn't able to speak.
He was a citizen of India as a man. He worked for the government.
He didn't want to.
All right, I don't want to hear anymore. Letter C, please.
I was actually referencing Annie Get Your Gun.
I'm sorry. I'm not as familiar with that as you would like. Please tell me letter C.
20.1 grams of H2SO4 dissolved in enough water to make 3.4 liters of solution.
Okay. So first, let's find out how many moles we have.
Okay, so H is 0 is 1.01. Two of those.
Okay, S
is 32.1.
and O
16.0.
That's 64.0 times 4, right?
Yeah.
So we've got Okay, so rules of precision tell me to get rid of that 2, right? I can only be precise. Rules of precision deal with adding and subtracting. Significant digits deal with multiplying and dividing, okay? If you don't remember the rules, please check the first module where they explain how to apply these rules. So we have 98.1 grams as our molecular weight. That means that 1 mole is that weight. So how many moles is 200, is 20.1 grams of H2SO4. So we're going to say 1 mole per 98.1 grams.
So
grams cancel, we'll end up with moles.
So basically what we're doing is
20.1
divided by
98.1. And we want 3 significant digits. So I'm not going to write down my extras. Oops. Moles. 0.025 mole. Okay? So now we know how many moles we have. We know how many liters we have. We can find the molarity. We say that 0.205 moles divided by 3.4 liters gives us typing in my little handy calculator, and we want 2 significant digits. Okay, so we're going to say 0.060 molarity. Okay, and that, please don't play with that. And that is the correct number of significant digits. That is the correct answer. If you wrote 0.06, you would be in error. I would mark it as wrong. If you wrote 6.0 times 10 to the negative 2, I would mark that as correct. Okay, molarity. The correct number of significant digits is 2. That's the point here. Okay? So that's it for 10.7. Thank you for joining us.